Hello everyone, my name is Atar Khan. I am Field Application Engineer in Jinko Solar Company for the energy storage system. Today I am here to discuss about the installation and commissioning of one of our product we call Giga all-in-one system. We have many requests from our overseas colleagues and our clients that they need some video, some tutorial to understand the basics of installation and commissioning of our products. So we have started to do these kind of videos. This is first of the video to show our product Giga's commissioning. There will be more videos about other products. This will keep going on. Before I start this video, I want to make one thing very clear to everybody who will watch this video and use this video in future. Installation and commissioning of any equipment is not that simple that it can be taught fully by a video or by a tutorial. Every site is different. Every site requirements are different. Some places you have to connect to the diesel generator. Some loads are different requirements. Some the foundation requirements are different. Every kind of field is different. So you cannot use one video to have a universal understanding of all kind of sites, of all installation. But this video will make you give you the basic understanding and how this installation work goes from beginning to the end, and then you will be able to understand this process. But if there's any project you want to install, but still you have to first contact with our engineers, with us, to make sure that the steps you follow and the steps that are required, they are in line. They're not separate. So let's start with our our commissioning installation tutorial. In order to understand any commissioning or installation of any product, first we need to understand the basics of that product. We need to understand the basic parameters, all the parameters of that product. We need to understand the structure, how the structure of that product is made, what are the configuration, what kind of components are there, which things are already done inside before it was sent, when the factory acceptance test was done, and which connection or which thing we need to do on the site. We need to do all these kind of things. So that's why first we need to know the basic parameters. We need to understand the basic structure and configuration. Then we need to know about the communication topology to understand how it will communicate in future after we finish the installation. Then we move to the installation and commissioning work. Then we go to the product operation, how the operation should be done, how it should be powered on, how it should be powered off. And in the end, in this tutorial, I have also included one case study, a very small case study of one of the project that I was on there. I was there in the site, and I have some pictures to explain to you that how actually on the site this installation look like and how it should be done. So this is all. Now we can start to the basic parameters of a Giga unit. We have divided it into three parts. We call it DC parameters, AC parameters, and system parameters. As you can see, this is a 3D model of our Giga cabinet. I'll call it a cabinet from now on. Giga is a bit difficult to keep saying again. We have divided into three parts: DC parameter, AC parameter, and system parameters. DC parameters, as you can see from the name, DC parameters are related to the part where everything is about the DC power. So the DC power is where it is the battery spec are there. The batteries are all the DC part. So we have a rated capacity of 215 kilowatt hour because there are 5 battery packs. Each battery pack is 43 kilowatt hour. The nominal voltage for the battery pack is for the cabinet is 768 volt, and the liquid cooling system we have used for the cooling of the system. We have liquid cooling. Every time you hear about the lithium batteries, the one thing you have to remember that every time you hear about the lithium batteries, there will be two terms they always be used. One is the BMS, one is the cooling system. These are the basic requirements for using the lithium batteries. So many places, many of the applications or many of the products, they use air cooling, but here we use liquid cooling, and each battery pack has inbuilt BMS inside. AC parameters, the second one, AC parameters are related to the part which convert DC into AC. That must be an inverter. So we have on the down there, we have an inverter which is 100 kilowatt, which is a 3-phase 4-wire connection, 3 phase, 1 neutral. The output voltage of the PCS is 400 volt, is a three-phase voltage. For the single phase is 220 volt. But in the down part, in the cooling, in the ACS PCS part, we do not use liquid cooling. It's used for the forced air cooling. Forced air cooling, like how to do it. On the front, you will see there will be 3 or 4 fans, and on the back of the cabinet there will be 2 more big fans which exhaust all the air from the inside from the battery. From the cabinet. System parameters are the operating temperature for this cabinet is -20 to 50 degrees centigrade, but these are extreme values. We have to keep it between the most favorable values, between 10 or 30 degrees centigrade. That's more favorable. And the container is made of metal. You need to see this. So there is anti-corrosion grade is C3. Protection level for this cabinet, this is IP54. This is only for the cabinet, not for the inside the batteries. They have different IP configuration for inside, but the cabinet is IP54 with the dimensions of 1.3 meters in the length, 1.3 meters for the width, and 2.3 meters for the height. Starting with the first place, we know about the structure and configuration of our cabinet. As you can see, on the left side is a 3D model of our Sangiga cabinet. On the middle, you can see this is a picture I have taken on one of the side for the master cabinet. And why I call it a master cabinet, I will tell you later. And this is the SLD single line diagram for our cabinet, for our master cabinet, where you can see the batteries which have then connected to the high voltage box and which supply power to the liquid cooling system, then connect to the AC, and this supply power to the fans, and then we connect to the main supply for the input and output power. In our Sangiga system, there are four basic units. The cabinet can be divided into 4 basic units. One, we call it water chilling unit. This is called water chilling unit, or we can call it liquid cool unit. The liquid cool unit is for supplying cooling liquid inside the container, inside the cabinet. Then there is a high voltage box, and then one part is for the PCS, and the upper part is all the packs, all the battery packs. And you can say the fifth part is, you can say, the body of the cabinet. You can say it's the fifth part of our cabinet. We are discussing now one by one all the parts. Moving to the first one, the battery packs. As you can see in the picture, the battery packs look like this. You can see all the cables, all the power cables are very well connected already. And the second you can see is all the communication cables are already connected. These pipes that you see, these pipes are used for taking the liquid from the liquid unit, and it goes into the plate. You see all these batteries are actually placed on this metal plate. This metal plate is hollow from inside, and the liquid that is used to cool down the batteries, to keep the batteries under the normal temperature, the liquid keeps coming from these pipes, and then it goes inside, then come from the other pipe, and keep moving from between all battery packs. And in this section, you can also see the liquid, the smoke detector. We have humidity detector, and then we have temperature detector. And on the back side, you can see that red small thing is for the fire extinguishing system. There is a fire extinguishing system which is installed in the back side. When you open the gate of the cabinet, master cabinet, you can see this screen, this HMI. What happens normally if you have been installing ESS systems, you will have noticed that there are 3 layers of BMS. First layer is in the battery pack. The second layer of the BMS is on the high voltage box, and the third is there is another level of third BMS, and that connect to the PCS. But what we have done here is the third layer of BMS and the EMS and the control for the PCS. It has been combined into single unit, a single HMI. We call this SCU. In the normal systems, you might have, if you have done the installation, you may have seen there are different HMIs, different control units. We have to control for the PCS, then for the BMS, for the EMS. But here we have the one single unit, which we call this SU. But this you can only see in the master cabinet, because the master cabinet is used to connect and control all the other slave units which we connect with with other cabinet that we connect together. One thing that I need to tell you here is we can install 9 Sun Giga units together. All these 9 Sun Giga units, they don't have any SCU, only the master cabinet have, and they all are connected here in this unit, and then this can control all of them together. This is the chiller unit. You can see more clearly in this picture. A chiller unit have 2 pipes, one for the for the input and one for the output of the liquid. And if you see this chiller unit, this side inside, if you open this side, you can see that chiller unit have a pump, have the liquid place where all the liquid is placed, and they have the meter gauge, and they also have a place for replacing the liquid, and there's all pressure gauge there. This is all already wired. Everything is done. You just have to make sure on the side that nothing is out of place. Third unit is the HV box. We call it high voltage box. A high voltage box is a combination of many equipments. We can also call it high voltage box is the middle unit between the DC power and the AC power. This is where the power comes from the batteries, and this is where this power is connected to the PCS. It has so many things inside. It has a DC switch. It has so many MCBs to control the units inside. Inside we have a second layer of BMS, which we call BCU. Inside we also have many contactors, sensors, and we have a AC/DC power supply. Why we need the AC/DC power supply inside also? Because some of the equipments, they need 24-volt power supply, but what we have is coming from outside is 220 volt. So we cannot use the 220 volt. So we have to put some converter here, and then we use that 24 volt to give power to all those equipments. And yeah, there is all of these are already pre-wired. When this unit leaves the factory, everything is pre-wired. You don't have to do anything on the side except this one cable. You see this one cable. When you open this container on this cabinet on the side, you see that this cable is not connected. Why? Because this cable is used to connect all the high voltage box to the SCU, and it has to be done through this network switch. So let's move to the PCS unit. We can know about this more. A PCS unit look like this. You can see here, this is the PCS inside, and it's already inside the cabinet, and this is the input-output connector. This is the network switch, which we connect all the communication from the slave to the master. And they have common neutral and the grounding network switch. They all are connected here, and they all also except this power cable and this AC cable, AC connection, and this communication connections all are already done. You don't have to do anything on the site. This is the same thing I have told before also, communication topology, how the communication between all these systems, all these units work. As I told you, the 9, we can connect 9 Sun Giga together. Normally, so far all the projects I have seen, we normally connect only 6 or 5 units together, but it can be extended to 9. First unit that I showed you is called master, the other are called slaves. And if you see from here, each pack have one BMU. This is also BMS, the first layer of BMS. Then all these BMS from the CAN communication, CAN bus bar connect to the BCU, the second layer of BMS, and this represents the high voltage box. And it has all the other units like sensors and contactors, circuit breaker. Then this is connected to the network switch, and this PCS is also connected to the PCS communication is also connected to the network switch. And this network switch, as I showed before, is connected to SCU. Is the final, the local EMS. We call it local controller. You can call it third layer of BMS. You can call it any there. There's a combination of all of them. And if you have any kind of external communication, if the customer want to have a SCADA system, have a third layer of EMS, and some other kind of equipment they want to communicate with the system, they can directly connect those systems directly to this SCU. And this SCU can also is connected to our cloud. All the data from these units can be seen on the cloud. Okay, now you must know everything about Sun Giga, everything about our Sun Giga all-in-one unit. Now we have to move towards the second step. Now we have to everything about. Now we move to the installation and commissioning of a unit, of a cabinet. before we start the communication, very sorry, before we start the commissioning, we need to make sure that the people working on the site, they are certified. Every country have different regulations. Every country have so many different laws, and not everybody can go to the site and start to do the commissioning because it's a high voltage equipment, and every high voltage equipment is a potential hazard. It can cause injuries. It can even cause fatal injuries. So every person who working on the site, it has to be a professional. Should have the professional electrician construction certificate recognized by the local laws. It should possess the ability to deal with the emergencies and handle related events according to the local laws and regulations when this product is used. It's also very important that anybody working on the site, it must have a little experience, and if it doesn't have a little experience, someone with the experience should be with the person. Any kind of emergency can happen. As I told, it's a high voltage equipment, so the person must know how to handle those emergency situations. The person who is doing all this lifting, his electrical connections, transportation, everything, they should also have the understanding of all the terms and conditions of this manual. I write here this manual. This manual means that when we transport our system, our cabinets to the site, we also provide them with the copies of installation manuals with the user manual and with operation manuals, all kind of manuals, and they must need to read. They must read all of them and should understand everything before they do this. So if they face some situation, they know what thing is stand for what. Preparation for installation tools. This is also one of the pre-requirements for the installation, for the commissioning. These are all the common equipments that we normally use for the commissioning and installation work. Some of them are very important that I'll mention here. Anybody working on the site must have an insulated gloves. You're doing the high voltage connections, and if you do not have an insulated gloves, you're putting yourself in a danger. You can get an electric shock. The second most important is insulated shoes. You should have it. You should have a safety helmet. Then you should have screwdrivers, and the last but not the least is the multimeters. You should have all this equipment, but the one I mentioned, they are very important. When you're working on the site, you must have all of these. Foundation and grounding. Okay, this is a picture I took from one of our site. This you can see there are 5 units connected here together, and there are 5 more units connected there. When we take the units to this site, before we take the site, we have to make a foundation. And before we make the foundation, we need to make sure what kind of foundation we need. You see these units, they are the cables that we take. They always actually take from the down. When you connect the cables or the communication cable or AC cables, you have to take it from down and up connect on this side. So if the one way is you can put the units on the floor, and you can make a duct there, and the duct can be used to take the cables in and out. But that kind of foundation or that kind of design cannot be suitable in many conditions. Like suppose there is a flooding, and if there's a big rain. So if there's a rain and the water accumulation is there, the water will eventually move inside the cabinets, because those points which we use to take input for the input and output of the cables, they are not waterproof. The water will go inside, so it's not feasible. The second point is the cables connection. You see the power cables. How do we connect the power cables? I will discuss later again. Just for the discussion, I tell here. These power cables have to be connected from each unit. Then we can take it to this next level wherever we are connecting our connecting wherever our kind of connecting point is. Maybe it's a distribution box. Maybe it's directly connected to the grid or whatever. When you take it from inside, so if there is no space down there, it must be very difficult to move the cables. So that's why we always suggest to our customers that every time you are making the foundation should be above from the ground level. It cannot be on the ground. It should be above for 2 reasons. One, for the movement of the cable, and the second is the communication cables. See, all these are units, the slave units. They all need to be connected with the master units, all communication cables. So when we take cables from there, and you move to here. So you might need someone who should, who should crawl inside and just take the cables by the hand and just took there and then move up from there and one by one keep moving the cables. So for this reason also there must be the foundation must be up there. So this is the this kind of foundation is the ideal one for our SunGiga product. It should always be above the ground level. These are some of the conditions for the climate. You have to be careful about the climate, environment, soil and geological conditions. If you are making the ground level, you should be sure enough that the ground is strong enough to hold the weight of the cabinets and the foundation. The cabinets are quite heavy. Each battery pack is almost 300 kilogram. So each only battery pack is almost 300 kilogram. I forgot the total weight. So this is very heavy. So ground condition should be very good. The cabinets should not be placed in any environment which is flammable or there is an explosive area nearby. This can cause this is a rule for every kind of installation. You cannot install these kind of units in a flammable place or an explosive place. The third is you're going to install the cabinets in an environment. Maybe someone is thinking about an indoor installation or some installation near some place where behind there some people are using that area. So there is some noise there. We are using big fans back there, and the fans are used to take all the air from down back there and exhaust outside. So there's some certain noise there, and you have to also make sure that the noise level is acceptable before you put the units there. So for the foundation, this kind of foundation is ideal, and you have to be careful about the ground. And the third is about the area, about the noise level or all these kind of things. Okay, here we are doing the installation steps. I can explain just I'm going to explain this one by one to you. So we divide the installation into three basic steps. One is we call it pre-installation, then the structural installation, then the electrical connections. What is pre-installation? In the pre-installation, you check the appearance of the cabinet. If there is no damage, you check that there is no damage to the devices inside. All the devices are intact, because when you're moving in the shapes, when you're moving in the truck, because of that movement, all the devices are intact inside. They have not dislodged there. Verify that all the parts are intact and do not missing. Confirm that the installation environment meets the requirement, and confirm the availability of the equipment for lifting outdoor cabinets at the project site. These are all the very common requirements that you have to be very careful about. Then the structural installation, you have to use some crane, or you have to use some lifting equipment to take the cabinets from the place of storage to the installation site, and then you have to fix the cabinets on the ground, the place you have foundation that you have made, and that foundation maybe if it is a metal based, you might need to do some welding. Then the last is electrical connection. The first this is the last one, and it's very easy because most of the connections, as I told you, is already done. You don't have to do more connections on the site. You only have to do 3 connections. One is connect to the ground point, the grounding point with your ground on the site. Connect the power cables, auxiliary power supply and communication lines. You have to connect them all together. This is one. Second. And the third is the communication of external communication and power cables. So they might need some external communication. Maybe you have a SCADA system, maybe you have some third-party EMS, all these kind of things. So you have to connect them with the external communication, external part, and you have to also make sure that all the external connections are done correctly. So these are the all installation steps that I'm going to introduce. I'm to lifting the cabinets. When you have received the cabinets and you have removed the outer cover, and then we have to move the cabinets to the site, and to the site you might need to use some cranes and some other kind of equipments, what call it forklift. We recommend that if you are using some crane, the crane capacity, lifting capacity should be between 5 tons to 8 tons, and at one point you can only lift one cabinet. It's not allowed that you can for the saving time you can try to lift two cabinets together. That may cause some damage to the equipment and maybe the personnel working on the site. So the lifting capacity is 5 tons to 8 tons. If you're using a forklift is used to carry from here. You can use the capacity of at least 5 tons is sufficient. And after the liquid cooling energy storage system, our cabinet is lifted and installed. The outdoor cabinet is fixed according to the project requirements. Now you have lifted. Now you have to put there, and this thing is according to the site. There is no rule for this. How you have designed your site, how you want to put it, it all depend on you. The well seams. The third point is for those kind of foundation which are made of metal. If you have made of metal, you might consider to bolt the cabinet with your foundation. Moving out, grounding. Okay, now we are moving to the connections. The first connection that we do is the grounding connection. As you can see in the cabinet, we have this copper strip. This strip is actually for the grounding connection, and from here you can use M10 size bolt, and you can connect all the grounding points that you have already made for the site with this, and then you can connect to your grounding points. This first part is done, grounding connection is done. Now the second is AC cable connection. Okay, you can see from here the AC cable connection. You see the cables coming from the down part, and you have to use the cable according to our user manual. We have in our manuals we have recommended different kind of cables that you can use, and you can also use the cable depending on your site conditions. Maybe you want to use some different kind of cables. So you can use the cables, but you have to be very careful about the phase sequence of the cable, because there are so many units. If you're connecting 8 or 9 units, the phase sequence should be same in all of them, and the best practice is to mark each phase with some color, so you do not make a mistake. If there's a phase sequence mistake when you connect with the grid, it can cause a phase sequence fault on the grid, and everything can trip. So you take from here, AC cables connect from here, and then you can connect to your system wherever you want to connect, where is a combiner box, where is directly connected to the grid, or what other side is this. The last is for the inside connections is the communication cable connections. As I told you before, that we have to on the site we need to do the communication cable connection for the high voltage box and for the PCS. When you open the back side of this side, on the back side, you find PCS look like this, and then you have to connect the cable, which we recommended communication cable Cat6 cable. You can connect with this LAN port here on the PCS, and then you can move to this network switch on the master cabinet, and the same with the high voltage box on there. There is no cable here. You will connect the same cable from similar kind of cable from this place, and you will connect on this network switch. This practice you have to repeat for each cabinet. It's not for one cabinet. If there are 5 cabinets, then for each cabinet you have to use 2 communication cables, one for HV box, one for the PCS, and then you can take all the cables down from there, and you can move from somewhere from here up inside here, and then you connect all of them with this network switch. Okay, this is the external connection. As I told you about the SCU, if you have some external equipment that need to communicate with the with our cabinet, with our product, we have to connect them with SCU. This is our SCU. This is the down part of the SCU, as I have shown you. Down part of the SCU, these ports are here. This is for the RS-485 communication, and this is the LAN ports. You can use the super category 6, like I said, Cat6 cable for connecting to the LAN, this port, or you can connect the RS-485 communication connect to any of these points. It depends on your device. This has to be confirmed from us first. If you have any device, you will talk with our solution engineers, talk with us, and we will tell you where to connect and how to connect. All the external communications are done. All the internal communication are done. and power cables are done. Now our system is ready to be powered on. After all the connections are done, all the communication cables, power cables, everything is done. Now our system is ready to be powered on. It's very simple. Now before we power on, we still need to do a pre-power check. We need to check everything. Why we need to check everything? This is a very important thing that if you don't know about the ESS system, or if you have commissioned any ESS system, you might know that ESS is not a simple device. Many people or many customers that I have talked with, or many of the people that who talk about the ESS, they consider ESS is just like a power bank. That, like, we have a power bank, we bought it and we just plug and play. We can just charge anything. But ESS is not that simple. You see, in the ESS there are battery packs. Each battery pack have BMS. BMS is another device. Then we have some cooling units. Then we have the second layer of BMS, and there is a high voltage box. There are so many equipments there, and they all need to be operated together. And there is a PCS, and the PCS also need to work and also communicate with other devices. Then we have a third layer of BMS. We have an EMS, and then we also have some external units. They all have the connection together, and they all are communicating with each other. And they also have so many protections and all these kind of things. And it's very complicated. It looks very simple, but it's very complicated. Now, if there is any problem happen, is any wire that is missing somewhere, or not fully tight, or is not working, what happens is the system do not operate properly. There's some kind of fault will show there on the screen. There's some error show there, and we will have to waste a lot of time to check the whole system, everything from the beginning to the end, only to find out this. So sometimes it might happen, and I also have encountered this one issue that one times, that there was some wire that was not fully connected, and we just see visually. We just made a visual I just visually see this, and we thought that everything is okay. Now why this fault is coming? And we just keep going through each part. Maybe it's coming from the EMS, maybe from this, because it's not easy to find out where it is coming from. Even the fault is showing this, but it's still because everything is connected. And finally, then we find out that there's one wire that was not fully connected. So when you are doing the check, you also have to do everything check with your hand, not fully hand, but you have to cover, and you have to check all the connections, that everything is made right. Otherwise, it's gonna be a lot of trouble when you are power up and the system is not working. First is check whether the circuit breaker in the electrical compartment is disconnected in the state. It's totally disconnected. We have to check it. Check whether all the circuit breakers in the HV box panel, they all are also disconnected. We have to check that all the serial cabinets between each battery packs is reliable. You have to check it that all the cables are in the battery packs. They're all very well connected. Power cables and communication cables. Check the connection terminals of all communication and power cables. As I said before, you have to check all the communication and power cables. Check whether the communication and power supply harness and power cables on the high voltage distribution box panels are properly connected. The same thing, you have to check all the communication and power cables on the HV box also. And you have to also check the network cable that you use. Now, that network cables you're using, it can have some issue. Maybe the network cables are not working properly, because we cannot supply network cables. Network cables have to be made on the site, or you have to make there, because it depends on the site size. Maybe your foundation and maybe your size is different. So it's not proper to supply the communication cables from here. You have to make it there, and you have to make sure the cables are totally made right. They're not wrong. If they make it wrong, then the communication will not work. If the communication will not work, the units will not power up. So check whether there are problems with all the network cables connection on the switchboard, and then 3-stage display and control liquid cooling energy storage integrated cabling. Okay, you have to check all of these things. After you have checked all these things, that everything is intact, everything is right, there's no problem, pre-power check is done. Now we are moving to the power up. Now pre-power check is done, and now we have to move to the power up. Power up system is very simple. It's not very difficult, unless if there is some fault happen. Power up procedure: you close the DC circuit breaker on the high voltage distribution box, and you close all circuit breakers in the distribution box. There are so many circuit breakers in the DC box. What you need to do is you switch on the DC switch, DC disconnector on the high voltage box. Then you switch on all the MCBs which are on the high voltage box. Then you move to the to the liquid cooling system. You switch it on, and then you move to the PCS side, and there's a AC switch there. There's a circuit breaker there. You switch on that circuit breaker. After the liquid cooling energy storage integrated cabinet is powered on, okay, now when the system is powered on, now you all have done everything. Now the system is powered on. The third stage BMS will automatically send a closing relay command to the second stage BMS in the high voltage box. Now, when the system is powered on, there are relays in the high voltage box. So when the third layer of the BMS is on with the SCU, it will send command to the high voltage box and to the relays to close, and those will close, and this power up will done. If the system power up is totally normal, if there is no problem, there is no fault, nothing else, the system will jump into the chargeable or dischargeable state. It will start charging or discharging. You can also set all these values, how much power you want for the charging, how much power for discharge. This can all be set in the SCU, and this cannot be described in this presentation. We can provide a manual for that, and you can learn from that how all these values are set in the SCU. Okay, the system is power up now. It's very simple. We move to the SCU. I would like to give you a basic view of how the SCU display look like. The SCU display look like this. You can see here. There are three basic main units you can see on the display. This one is the basic information module on this side. Then this is the EMS data. It's an EMS, and there on this side you can see all the fault. Here you will find the operating mode of the system. If the system is not ready to work, it will show here. It's not ready. If it is okay, totally okay, but you're not drawing any charging or discharging, it will go to the standby. If it's discharging, charging, if it is an alarm, it will show the alarm. If there's a fault, it will show the fault here. And on this side, you can see is this all our batteries, battery packs or slave cabinets, you can say it. When you click on this, you can see all the data there. When you click on this, you can all the data for the particular cabinet there. And for this is for the PCS. When you click on this part, you can see all the data related to the PCSs, all the PCS that are connected. You can see all the data even down to the cell level. All the data can be seen from here. And this is the EMS level. They will show you the total charging capacity, how much discharge in one day, how much charge. All this kind of information can be seen here. And all this information can also be seen on our cloud. This is all connected to the cloud. We insert a SIM card in the SCU, and it is connected to the cloud, and then you can see all this information there also. And if there's any fault, it will show down here. This is the same thing. We talk about how many modes are there in our SCU. There's all the modes: standby, discharging, charging. This is one of the project. Sorry, as I have already shown you the picture before also, the same product. This one of our project that I was in there. They have 10 units, but they separate in 5 units, 5 units and 5 units, which has one master and other slave. The one master cabinet and the 4 slave cabinets, they all are placed like this. This is the foundation, and the cables from inside all goes to up there. There was a distribution box up there. I will show you what kind of distribution box. So this distribution box and if the external equipments, it depends. It's not provided by us normally. It depends on the site. It can be or cannot be. It depends how this communication before the project was executed was done. I'm showing you this one example of the high voltage box. Combiner box, how it was done, and see all these are connected together. You can also see this. Okay, this is the distribution box. You see all those power cables that come from each cabinet. Each cabinet the power cable come from. It comes to connect with here. Like this one switch, this one disconnector is for first cabinet. This for second, third, fourth, 5, 6. Because this is from other project, so there are 6. And see this, they're all the same thing. It's the back side. You see all units are connected here, and then they are connected to the main bus bar. And this main bus bar is connected to where? It's connected to a main circuit breaker. The main circuit breaker, so you can take the switch off the whole grid supply directly. You can the grid supply is coming from somewhere there, and it's connect here. Grid and load all there. and there are some indicators for the fault, for the normal operation. Some customers, they also want to connect the meter, power meter, is for the measurement of the power coming and going. So this is one of the typical example of one distribution box, where we connect all together, and we can you can put the whole control of the power of all the connected units in one place. And it also depends on different sites. The sites can be different. So this normally it's look like this. We have talked about this one, and that's all about the this all presentation, all about this tutorial. You can contact us, or you can send an email, and we can tell you more about this and can explain to you everything about this. Thank you.